organic conversions related to the lessons so far we have completed, right? Alkane, alkene, and alkyne. The very first one, we have done this under the preparation of alkane. If you have aldehyde ketone like this is an aldehyde. This compound is called an aldehyde. Aldehyde may have only one carbon attached. The actual structure of this one is like this. Right? So in aldehyde, there is a double bonded oxygen in carbon, and that carbon may be a terminal carbon. Why? There must be a hydrogen atom attached to the carbonyl carbon. This carbon is known as the carbonyl carbon. Which carbon? The carbon which is bonded to oxygen with a double bond like this. So carbonyl carbon has attached to only one carbon, and the other one must necessarily be the hydrogen. Then this is called an aldehyde. And this one is called a ketone. Ketone may have two carbon attached to the carbonyl carbon. Right? This is called the carbonyl carbon, and two carbon attached to that carbon is known as the ketone. This is an aldehyde. This is a ketone. Then aldehyde to ketone can be, this oxygen can be removed and two hydrogen can be attached to that carbon just by adding zinc, Hg, conc, HCl. Zinc, Hg, conc, HCl. If you add that, then you can convert this into alkane. Alkane is the compound having only the carbon and hydrogen, and all the bonds are single bonds in between any two carbon atom. If the bond is single bond, then it is called, such hydrocarbons are called the alkane. Then you can convert any aldehyde or ketone into alkane using this method. Instead of this HCl, you can use DCl. DCl means another isotope of this hydrogen. So Zn Hg. Now I can use conc DCl. This is same as the HCl. This is the deuterium. 1H1 is called hydrogen or protium. 2H1 is called the deuterium. This is chemically same as hydrogen. Right? Why? The chemical properties of isotopes are same. Then you will get two D atoms attached to the carbon atom instead of these two. This double bond or two bonds of this oxygen. So you can get this as the product. Then second one is the ketone. If you have a ketone, then ketone can also be converted into the corresponding alkane just by adding Zn, Hg, conc, HCl. Then you will get this product. In the same way, you can add Zn, Hg, conc, DCl. Then instead of this oxygen, you will get two deuterium atoms attached to that, like this. So aldehyde or ketone can be reacted with ZnHg, conc HCl. This is known as the Clemmensen reagent, and we have already done that under the preparation of this alkane. Then the third one, you can convert alkyl halide into corresponding alkane. In the aldehyde ketone case, the number of carbon cannot be changed. The number of carbon will remain same as the number of carbon present in the aldehyde ketone. Even in this case. In this case, how you can convert that? First, you need to convert this into Grignard reagent. Grignard reagent means in between this carbon and chlorine, you can add magnesium atom. Say you have CH3, MgCl. That is the product you can obtain. So for that, you have to add magnesium and dry ether. Magnesium and dry ether. Then you will get this product. This is known as the Grignard reagent. And for the Grignard reagent, you can add water or any acid or ammonia. Or there are a few compounds. You can go through the note and check it. Then you can remove this MgCl and add hydrogen atom to that. Or in this case also you can add, instead of this water, or sometimes you can add say HCl. Even HCl will work with this. Water or HCl, right? Not both. One of them is enough. And here also you can use D2O, deuterium oxide, or this is same as water. Then you will get CH3, and another D atom will be attached to that. Instead of this D2O, you can add DCl. Then you will get the same product. Not both, right? One of them is enough. This DCl must be pure or dissolved in D2O, not in HCl. If you dissolve that in water, the normal water, that means H2O, there may be some having CH4 and some may be CH3D. Maybe mixture of compound depending on the concentrations, amounts, and many factors will decide the product you obtain at the end. Then the fourth one, in the same way, you can convert that into, let's see, yes. Here, the fourth one, yeah, here it had the chlorine atom here, right? It was chlorine Cl. Yes. Now, if you have Cl here, again you can add the same thing. Dry ether magnesium, dry ether, and magnesium, then you will get CH3, CH, CH3, and MgCl here. Then you can add water into this, ODCl, water, OHCl, or any dilute acid, or even you can add the alkyne having terminal hydrogen. This is called alkyne having terminal hydrogen. Terminal hydrogen means hydrogen attached to the triple bonded carbon. This one O, you can add many things. Water O, HCl O, ammonia O, dot dot dot. I have given you some compounds which you can use to remove this MgCl part and add hydrogen into that. That means you can replace this MgCl by hydrogen atom just by putting all these things. Right. That is the fourth one. Then the fifth one. Check whether you have done all these things in the correct way as I am doing. And if you have some other method or other reagents, there may be some possible reagents for some conversions. So if you have used them, let me know, then I will give you some. Okay, in this case, it is D atom. That means this chlorine has been replaced by deuterium atom. So you can now use what is magnesium, dry it, then you will get that the CH3CH and CH3 MgCl. Then you can add D2O-DCl. D2O ODCl, not both. One of them is enough. Then you will get this product. That is again the Grignard reagent. This is called the Grignard reagent, right? Grignard reagent. Then the sixth one, we need CCl4 from the CH4. For this one, you can simply use chlorine and H nu. H nu means here you can use H nu means the energy, radiation energy from radiations. H nu, or you can use that light. Which light? Diffuse sunlight. Light. The energy from light may be enough. Diffuse sunlight, especially the sunlight, is enough. That means the energy carried by that sunlight is enough to carry out this particular reaction. So all the hydrogen atoms will replace one by one through a chain of reaction. We call that chain propagation reaction. In this case, the reaction is special, that is going through radicals. So free radical chain propagation reaction is occurred and giving the CCl4 at the end. Then the next one, the seventh one. Here also, this is the chlorination of toluene. Again, you can go through the note and just reminding these things. I use this conversion to remind, that means as a recap of the past lessons. Now, here again, you can get, you can add Cl2 and sunlight. In this case, you have to use diffuse sunlight. Diffuse sunlight, that means that not the direct sunlight. If you use direct sunlight, the reaction may be different. I have given you that also. So please go through the note and refresh your knowledge. Then the eighth one. Here you have to add only 2 Cl2. Actually, these reactions are not much easy as we write. But anyhow, you can get some of the CHCl2 product. If you try in this way, you have to use 2 moles of Cl2 with diffuse sunlight. Then you will get this product. That means if you need 2 chlorine atoms, then you have to use 1 mole of this with 2 moles of chlorine. Actually, even in this case, you will get this CCl3 product, but that will be the minor product. The major product may be this one, but can't guarantee, because these are free radical reactions. Normally, we don't do the free radical reaction in our conversions because the amount of product cannot be predicted. That is not sure. Because free radicals are free radicals. They are highly reactive. We can't control the reaction. It happens on way. So anyhow, this can be done. Can be done. Maybe the minor product. This product may be a minor product. That means the percentage, as a percentage, it will get only a 20% of this product. But still you can do, then if you have some amount, then you can distill of that. by using the fractional distillation method, and then finally get this. Then if you need only one chlorine, then again you have to control the reaction. It says that in books, it says you can control the reaction only in the case of this toluene, but not in the case of, if you need to substitute only one chlorine, hydrogen atom by chlorine, using this CCl4, actually it is not possible according to the books, right? So even here you can use, how you can use or add only 1 mole of Cl2 with the sunlight. That means you can use 1 mole of toluene with 1 mole of chlorine and expose that to sunlight. Then you will get this product as one of the product. It will be a mixture of product. One of the product will be this one. Depending on the boiling point of that, you can distill off it, right? So you will get the product. And the 10th one will be like this. Here you have CH3, only D3. So in this case, you can convert this into, first you can convert this into CCl3, and then you can turn that into this one, MgCl. MgCl may be highly unstable, but as a theory we can do it, but I don't know practically how it can do, right? So here what you have to do is you have to add Cl2. In this case, you have to add excess of chlorine, then you will get this product with the sunlight. Then you will get chlorine attached to this. Then you can add magnesium and dry ether, this product, and finally you will add D2OODCl. Then you will get the product like this, deuterium substituted toluene. All these I think I have done in the theory part, so you can go through that. Then the 11th one. This is just to refresh your memory. Here again the same thing. What you have to do is you have to prepare this by using same as that 8th one. Using that 2 moles of chlorine, you can add Cl2 and chlorine, the sunlight, then you will get this product CHCl2. Then you can add, in the same way you can add dry and magnesium, then turn that into MgCl, and then add water, then you will get the required product. So I am not going to do it again because I have already done. Then you can do it and get the answer. You have to try by yourself. This one, the 12th one, it is same as the this one. Right now, here you can use a special technique in this case. First, you turn this into the above product like this. Cl and H. That means only 2 chlorine hydrogen atoms has to be replaced by this chlorine. Then you can turn this into this product. Actually, this is an intermediate. No need to write down. If you get that in your exam, A-level exam, then no need to write down this step. This is intermediate product. So I will write it in square bracket. So intermediate. Why? Having 2 OH groups on the same carbon is highly unstable. Therefore, what happens? It will remove a water molecule. It will remove a water molecule like this and convert that into this product. Means it is called the rearranging of that. So you will get this. Right? So will be the product. So here to here you can add 2 moles of Cl2 and here sunlight, diffuse sunlight. Then you will get this product, and here to here you can add sodium hydroxide, but actually straight away you can add the sodium hydroxide into this without writing the intermediate. No need to write down that intermediate. Straight away you can add sodium hydroxide into this, then you will get the product like this, right? But I just wrote this to get known about that having two OH groups on the same carbon is unstable. That is unstable. So it will rearrange. That means a water molecule will be removed. So it is an intermediate, unstable intermediate, right? Unstable. Unstable intermediate, and it will convert into this benzaldehyde. This is called benzaldehyde. Then the 13th one, actually, I think I have given you the theory, but remember that this is not in our syllabus. No need to know about this according to the present syllabus, but as I have given you this, I will let you know how to do it. Here even I can't highlight it. Anyhow, let's see what is wasting. Yeah. Here we have what? Oxygen and all the CH2, CH3 and CH3 like this. Right? So you can add this to get it. It is not in our syllabus, but anyhow, if you find in some books or papers, then you can do it. For this, actually, what we need to add is this. You have to add soda lime. Soda lime means sodium hydroxide and calcium oxide mixture, and then you can heat. Then what happens? A water molecule will be removed. Sorry, the carbon dioxide molecule will be removed. That means in the product, you will have only 3 carbon, but here you have 4 carbon. Means you can reduce the number of carbon by using this method. If you need to remove just 1 carbon from the carbon chain, then you can convert a terminal hydrogen atom or the terminal carbon atom into carboxylic acid, because this is called carboxylic acid. And then add soda lime, then you will remove and get the corresponding alkane to that particular reaction. Right? If you have 4 carbon, you will end up with 3 carbon. If you add, depending on the compound you have, you can get this kind of a product. Even if you have this benzene ring with carboxylic group, this is called the benzoic acid, then you can convert that into benzene plus CO2. That CO2 is the CO2 which we remove from this carboxylic acid. So you can add sodium or potassium hydroxide with the calcium oxide and then heat, then you will get this one. Right? It's also called this the soda lime method. Right? By you adding soda lime and heating will give us the such product. Then the 14th one, you can see that in your note, I have done in the same way this question. So this is another special reaction, means when you have to say functional groups or something like that, then you have to first protect one, because Oh my God. Yes, we have to convert that into this. How you can convert it? First, you better to remove this chlorine. You better to remove this chlorine and try it. Otherwise, it will be a bit hard. Because this, if you convert this CH3 group into this first and then try to do the other one, so it will not be a good procedure because this we need to convert this chlorine into Grignard reagent. So when we convert that into Grignard reagent, that Grignard reagent will react with this aldehyde. Normally aldehyde react with Grignard reagent. Therefore, what we need to do is you have to first remove this chlorine and then try with the CH3 group, right? So first you can convert this into MgCl, and here you have CH3 group. Then you can add D2O, and then you will get D atom attached to that, and then CH3. Now there are several methods of doing this. I will show you in different colors, the different method with different color. First is single step reaction. What you need to do, you have to add MnO2 and uh, concentrated H2SO4. No, actually the dilute H2SO4 may be enough. Then you will get this product straight away. There is one method of doing that, which is not widely used in our syllabus, but that there is such reaction. Right? Another method of doing that, converter. Conversion of that into this. So you can use this. First you convert that into, here you have the D, and you can convert this into Cl and Cl and hydrogen, and then convert this into that. In this case, first you can add sodium hydroxide. Just to add sodium hydroxide, then this Cl atoms will replaced by these OH groups, and then having two OH groups on the same carbon is unstable, so it happens. I have given you two methods of doing that. And there are some other methods also, but I'm not going to go in detail right here. But later on, you will understand that. Right? Okay. So then the 14th one is that, then the 15th one. And today the meeting will end within 40 minutes, right? Just after 40 minutes, this is a limited package. Not like in the last week, right? So today the meeting will interrupt it. If it ends, then you can reload using the same link. Right here, D2. It's D2. Again, first you, in this case, as we have this aldehyde group, you can't convert this chlorine into a Grignard reagent. Why? If you do it, the CHO group will react with that Grignard reagent once you prepare it. Therefore, what we do is we just get like this. First, you have to remove this group. How you can do it? You can just try it this way. Is in Hg conc DCl. Then you will get this product. You have been seen it. Then you can convert this into two deuterium atoms, Dd and H. and Cl will still available. Then this chlorine, right? Not hydrogen, it is chlorine. Then you can now remove this chlorine in this way. How? First step, dry the magnesium to convert that into Grignard reagent, and then you have here CHD2. And then this you can convert this into this D by adding say DCA. Right. Or T2O DCl can be used in this conversion. And remember that Putha, this is the addition of Mg dry ether. Oh, straight away you can write down first step and second step. Means this is called the hydrolysis process. Hydrolysis step can be skipped. In a way, they can be combined. First step, you have to add magnesium dry ether. In the second step, you can add D2O. Then you will get this product. That means no need to show that in separate steps.